Have you tried Music to Code By yet? Well, why not? Here's a comment Joe left on the website. This is also great music to mow by. I like listening to music while doing yard work to help the monotony of it seem less tedious. This past summer, I started listening to these tracks while doing yard work, and they worked great. I could let the music play in the background without focusing on it, and it seemed to help me concentrate on getting through my tasks. Thanks, Joe. And you know, now you can download the entire 13-track collection. That's over 5.5 hours of music to code by for only $39. Check it out at musictocodeby.net.
It's .NET Rocks!
Well, that's what I'm talking about.
I have never seen a room with this many Vikings in it before. Just unbelievable. We're in Stockholm at DevIntersection Europe.
Yes, we are. And excited to be here. It's a great day in Stockholm.
Yeah,
not that we've been outside all day, but it's been really nice.
It's a wonderful conference. It's new for you guys. It's kind of small, but man, there's so much heart here and so much great content.
Well, it's the launch of Core 2, so there's a lot going on.
Yeah.
You know, I think we're still just getting our head around it. I got to open with the history of .NET, so it's like let's talk about the past because we're going to spend the rest of the days talking about the future.
Yeah, and Scott Hunter is here, right? Mads Torgerson is here. Like Miguel de Icaza is here. It's like an all-star studded cast, and you guys have exclusive access to all this stuff. So I'm hoping you're enjoying. You enjoying the conference? Yeah. Awesome. Well, this is an artificial intelligence panel, and we're going to introduce them in just a minute. But before we do, we have this little matter of a thing I call better know a framework. Roll the crazy music.
All right, buddy, what do you got?
Well, I was in the speaker's lounge just sort of I was actually trying to code, but when you're trying to code and Mads Torgerson and Scott Hunter and Miguel de Icaza are having a conversation about anything, there's just no, you're on that, right? So I couldn't do that. So I went looking for cool Twitter fodder, and I found this incredibly cool Twitter account that you probably know. But it's the name of it is Science GIFs, but the handle is learn_things.
That's cool.
And the first thing I saw was an animated GIF about how a piano key works. Yeah, there it is. And it looks almost like one of those birds, that dunks its head in the water, those mechanical birds. But it was really cool. And then I got looking at some of the other stuff, like you'll like this one, Richard. Taking a pound of sodium and skipping it on a lake. Sodium and water, what could go wrong?
Yeah.
So it skips out and it hits and it explodes and the sodium thing goes flying up in the air and then it comes down into the water and explodes again and it continues to go until it
If you ever get your hands on elemental sodium, don't flush it down the toilet.
No.
Ask me how I know.
But this was such a time vampire that I actually passed an entire hour just looking at all of these animated GIFs of things that you can do with science. So that's what I got. Awesome. And I'm sorry, and I'm sorry to your boss for wasting your time.
There you go. Yeah, you just got time vacuumed right.
That's right. So who's talking to us today, Richard?
Grabbed a comment off of show 1413, the one we did at NDC London, talking about machine learning. And that was with Jennifer Marsman, Evelina Gabrasova, and Barbara Fasinka, as you recall.
Yep.
Great conversation, all coming at machine learning from different angles. And I think it's probably fairly relevant to what we're talking about today.
Right.
And Matthew Cruz says, in the show you mentioned you were looking for practical use cases for machine learning and that most of the things you've seen at this point have been fairly toy examples. Here's a practical application for you, optimized for product ordering based on marketplace data. I work at an online retailer, and we have had R in production for several years. We use it to analyze how our various products are performing across several marketplaces. It helps us identify when products are at risk of becoming unprofitable and find new opportunities. Every new item we bring on has gone through a series of statistical models to evaluate the possible profitability and risk associated with the product. All of these decisions are based on machine learning algorithms. Being able to use them, though, is predicated on having sufficient high-quality data in order to make valid statistical inferences. One of the things that people need to be aware of before applying machine learning methods is to know when the results are actually meaningful or not. This is where some expertise is required so that the tools are not misapplied. There's nothing magical about machine learning. It is just a set of algorithms which were not practical in this era until massive storage and computational resources were available. And he goes on with the different models and so forth. I mean, what's interesting is you can tell that Matthew's now done machine learning long enough that he speaks like a machine learning person, which means we no longer understand him. Which makes, it's interesting how quickly that actually takes a hold. But it is fun to see someone who is clearly working on the different models and sort of taking more of the guesswork out of how they pick their products. They actually have a model that works from that. So, Matthew, thank you so much for your comment. A .NET Rocks mug is on its way to you. And if you'd like a .NET Rocks mug, write a comment on the website at .NETRocks.com or via any of our social media, because we publish every show to Facebook and Google+. And if you comment there, we read it on the show, we'll send you a mug.
And definitely follow us on Twitter. I'm at Carl Franklin, and he's at Rich Campbell. Send us a tweet. We skip them with sodium. I don't know.
Nice. You can do it with
we blow
potassium,
them up.
too.
We blow them up. How's that?
You can do them with potassium, too.
Well, now that's just crazy.
It's just a bigger bounce. Ask me how I know.
All right. So we're here talking about artificial intelligence with an esteemed panel. All the way to my right, Tess Ferrandez is here. To her left, Jessica Engstrom. And last but certainly not least, the inimitable Seth Juarez. Now, this is where I usually say something witty to prove I know something about the topic, and I really don't know a whole lot about this, so I'm just going to let the experts speak. The only thing I am going to say is I've been kind of annoyed lately by how the mainstream press treats terms like AI, machine learning, big data. Oh, heck, let's even throw cloud computing in there. And just how these terms get hijacked for marketing speak, and then people start to use them in ways that they should not use them. And the end result is that, heck, we as software developers are confused enough. Now, you know, your mother and father are even more confused. And so trying to have a conversation with anybody isn't possible. That's just my personal take on it. I'm going to open up the floor, and whoever...
Oh,
thank you, sir.
Agreement from the audience there. I know that Seth Juarez is annoyed by this, too.
Yeah.
Well,
I hear about it all the time.
I don't know if I'm annoyed by it. I think my take on artificial intelligence is very different than I think what other people's take. Like, to me, AI is glorified counting or just glorified search.
Yeah.
Like, if you think about it, right? I mean,
That's fairly glorified.
Oh, like finding patterns in data.
It's like the reason why it looks so awesome is because machine learning can only answer like 5 questions. And when you put all those questions together in a novel way, it looks intelligent, but it really isn't.
Yeah.
So to prove that, actually, we were talking with Miguel today in the Speakers Lounge, and he was showing AI in a different way. Pigeons as a service.
That's right.
Pigeons is a service.
Pigeons as a service.
Yeah, you need to look that up.
They could train pigeons to detect cancer by
Excellent.
feeding them. They would show them 2 pictures, one with cancer and one without, and the pigeons would learn to point to the right one. And there's a real paper.
Yeah, amazing.
That is amazing.
Wow.
Yeah,
Now,
but you need to know
how
Spanish.
artificial that intelligence is.
I mean, but
How accurate are they?
Oh, they were very accurate. 99%,
Yeah.
I think.
Really?
Yeah.
So
it was
better than
ridiculous.
doctors.
Oh, absolutely.
They were better than doctors. So when people talk about AI, usually, like, the people that are using AI correctly aren't talking about it, and the people that are talking a lot about AI are selling you something.
Nice. Yeah. I feel like AI has descended into the realm of ActiveX
Sure.
and Agile and Cloud, where
Sure.
it's just been subverted by marketing terms, and everything has that label now.
Yeah.
One of the reasons I asked all of you on the panel was that I thought each of you is working in a technology that maybe a year or two ago had a different name. and now it's been bundled under AI.
Correct.
And would you disagree? Like you've done some machine learning stuff, Tess,
Yeah, so...
and also chatbots, as I recall.
Yeah. So I did chatbots last year. This year is machine learning.
Yeah.
Woohoo!
Yeah.
No, but I've been doing kind of data analytics for a while and looking at memory dumps and things and finding patterns, and that's pretty much all there is.
Actually, when we first met you, you were reading you were
Debugging.
reading debugging dumps. So you've always
Yeah.
been in AI, really. You've done pattern matching for decades.
Yeah.
We
so
just call it
tomorrow, both
I.
me and Seth will sell you AI, I guess.
That's right. We talk about it because we work for a company that sells it too.
I won't be happy until we get a sticker that says AI inside on your laptop.
Well, there was a phone manufacturer that made a AI chip.
Nice.
I don't even know what that means.
Yeah, what does that
Is it
mean?
like GPU
It's
could
a-
be considered an AI chip, right? An FPGA can be an AI chip.
Yep.
A processor can be an AI chip.
No.
I mean, the thing
Apparently, a pigeon can be an AI.
apparently a pigeon can be an AI
But
chip.
isn't it artificial intelligence, or isn't that just
Intelligence.
Yeah, I don't know. Pigeons, intelligent.
I don't know.
So are we saying then that artificial intelligence is a perception, not necessarily a benchmark or a technology?
Well, today it's like Richard said, everything is AI. Wherever you look, it's AI. But what is it? Is it everything? Is it nothing? It's
That's a
like-
good question. Anybody got an answer?
So here's my particular approach to it.
The mathematician.
And I am more of a theoretical guy. I study these things, but I have never used them in practice. So, I mean, I've used them in practice for certain things. I write a machine learning library in .NET that
Numal?
maybe somebody uses. I'm not sure. Because like I said, they never tell you when it works because they don't
Right.
want you to know how you did it. Because if they tell me I use this algorithm and I have this data, I can replicate their work in a way. Right. And so they're not going to tell me because that's some seriously good IP. And so the way I think of AI is I start with what I like to call, and this again is not scientific. This is how I think about it. To me, there's hard AI and there's soft AI. Hard AI is like when you're solving a chess problem or when you're playing tic-tac-toe, right? Because that, and if you think of the algorithm to do, like, it's called adversarial search, something like Minimax. When you were playing tic-tac-toe, for example, you put your X there, and then the computer lays out everywhere that they can put the O. And then for every O that they put, you lay out everywhere you can place an X, and then an O, and then an X, until you build this tree, which is about 8 deep, right? Because there's only so many moves that you can do, or maybe a little bit more, maybe my math is wrong. And then you search the one that's going to get you to win.
Yeah.
It's called Minimax. It's called adversarial search. It's how you do it in chess. It's how you do it in tic-tac-toe. Is that considered AI? To me, it is.
It becomes a little bit more difficult if you're talking about, like, for example, self-driving car.
Yeah. And so notice that. So when we're talking about hard AI, I'm thinking of problems like that. When I think about soft AI, I'm thinking about the search space being infinitely larger. Right? Because the search when you're searching in chess, while it's huge, it's still finite. But when you're driving a car, the search space is infinite, right? Because something could walk in front of you that you've never seen, and you got to be able to know what that is.
Right, yeah.
And so for me, I separate into hard AI, which is the search problem, which is, like A-star, Minimax, and those kinds of algorithms. And then I think of soft AI, the things that use probabilistic methods or statistics or machine learning to come up with answers. And that's how I separate it in my head. That's not necessarily what scientists think. That's just how I separate it.
That's
but
good
to
enough
me,
for
it's
me.
the same. It's all AI.
But to me, it's more like we have traditional ways of developing applications, and suddenly we're expecting more from applications. We're expecting them to be more personal. We're expecting them to know more about us, to maybe extract data from or extract information from what we've said on social media or how we've acted or whatever.
Context.
And then, and put things in context. And that's where we need to do something a little bit different than just ifs and else's. And that's where we kind of need machines to learn more like people do from experience rather than just by rules that we come up with. And that's, to me, what machine learning and AI is. Like sifting through large amounts of data and finding those patterns and making things more personal.
And I agree. I just think like the bubble for AI is big. And, those kind of algorithms are in there that I was talking about, like the search algorithms. Machine learning is a bubble that fits nicely inside of AI. And then the newest craze of deep learning is a littler bubble that fits inside of machine learning.
Even narrower piece of that.
Because it happens to be a very specific algorithm that fits inside of machine learning. And so that's how I think of AI. I think of anything that's intelligence computer-wise fits in this huge bubble. Machine learning then becomes a subset. Deep learning, which is the new hotness, is another subset. That's how I think about it.
I want to jump back to deep learning in a bit, but Jess, what thing have you been working on that now they're talking to you about it being AI when it wasn't last year?
Well, I think everything is AI. I'm not sure. Everything is intelligent. You have smartwatches,
right?
Where you have everything is smart and somehow smart and intelligent. Yeah, exactly. At least they say that it is. But like if you take the smartwatch, it's not that smart unless you have added functions like Tess was talking about. Like if you have Cortana, which actually had context other than you reach your goals today, like you walk 10,000 steps or something.
I think most of those devices count on the cloud, that all the smarts are actually living in the cloud.
Yeah.
That's really what I think this craze of AI has really come from, the fact that we're harnessing more and more cloud resources to just, you don't realize that your interface, whether it's your phone or your watch or any other little device, is actually got a huge pile of servers behind it or a huge pile of GPUs.
Let's face it, the cognitive services, not just from Microsoft, but from Amazon, from Google or whatever, getting really sophisticated and really high level. Just send us a picture, we'll tell you what it is kind of stuff. It's really getting pretty scary. Scary smart.
It's cool from a dev point of view when you just go greenfield and look at the services that are available and go, well, I don't have to figure out any of this stuff. I just send the picture up and say, what's this? And
that's a little different than, the stuff, Seth, that you're used to, which is, kind of crushing the numbers and figuring stuff out.
One thing that's been included in AI, sorry to interrupt, recently is bots, which traditionally, like when you look at it, it's like a function. You work in bots. Do you not? Tell us about those.
Well, we started out, what year was that? 2002? When we did the MSN bot? I don't remember. 2006. Okay, so it's not that long ago. Well, let's see.
That's a long time. Like computer years. That's like 15 years.
Yeah, but we weren't talking about intelligent bots back then. It was basically a SAML file where you have, if they said this, do that. But today, like you were when you talked about chatbots, they are intelligent. But it's basically the same thing. Well, they're
intelligent in the sense like they use services that understand your speech and kind of can translate even if you haven't put in exactly that word or that sentence, it still understands it because it started to build models for natural languages that can translate just intents to other things.
Yeah, and that's what I love about cognitive services like Azure's or whatever platform you're wanting to use. Because we don't need to train them that hard. Because I remember how we had a TV bot, so you could ask when the next whatever show you're watching is on. But we got so many different types of questions for that single question for one single show. Yeah. So we actually had to manually go in and fix that. So we had huge list. I think OC was the series of that year, and gosh, did we have questions. I think we had probably like 80 different utterances or whatever you want to call them for just one show.
You had to think of all the variations.
Yeah.
And I don't think you have to do that anymore.
No, not if you use one of those ready-made services.
Well, my experience with the speech recognition stuff lately has been, I'm pretty amazed because, back in the days when we did it on one box, when I'm talking about, 5 years ago, we did it on a box where you had a speech recognition engine and, it kind of tried to figure out what you were saying, but in some cases it gave you this phonetic stuff that didn't make any sense, right? Well, what they can do in the cloud, and I know they're doing this, they search the internet for stuff that is phonetically spelled a certain way that you may have said, and they find, oh yeah, there's a really good probability that they said this. It could be a brand name, it could be a scientific term, it could be something that, your typical speech recognition engine grammar isn't going to have. Mm-hmm. And so I think that's just really cool and powerful that, once it's in the cloud and somebody like a Google or a Microsoft gets a hold of it, the power just goes up exponentially.
Now, you were talking about search. I know you weren't talking about search, but like search is a way to find an answer. But the difference, for example, with search now and what it used to be is a number of years ago, where, for example, Yahoo, you would search for something and it would literally pick out like the words you were searching for and looking at that from like in a big set of data, whereas now it can put intelligence behind things. So if you're asking for, I don't know, John Lennon's wife or John Lennon's first wife, it will know that that is what you're talking about, and not just documents that contain John Lennon first wife, which is kind of significant because search terms or search results that wouldn't show up before because they weren't necessarily in that context can now show up instead.
Yeah.
So
we had to use operators like question marks and plus signs and minus signs and stuff like that, but we don't have to use that anymore.
Yeah. I'm going to ask you guys to hold that thought while we just take a minute to pay our bills. This portion of .NET Rocks is brought to you by our friends at JetBrains. Hey, how often do you profile memory usage in your .NET apps? What if you could automate memory usage checks so that they're executed every time you commit a change? You can actually do that with .memory unit from JetBrains. .memory unit is a free unit testing framework for monitoring .NET memory usage. You write unit tests that check your code for all kinds of memory issues, and then run the tests on your machine or in a continuous integration server like TeamCity or VSTS, just like you do with regular unit tests. You can track how much memory is allocated, check memory for objects of a specific type to prevent memory leaks, or compare several memory snapshots in a unit test to see if memory usage is creeping up. Learn more and download .memory unit from jetbrains.netrocks.com, or just search for a package called .memory unit on the NuGet gallery. And we're back on .NET Rocks. Carl Franklin and Richard Campbell here talking about AI, or at least, what it means and what our experiences have been in these last couple of years. Who wants to pick up where we left off? We were just talking about how the cloud services are just getting smarter and smarter and not requiring us to do a whole lot of real work in AI and machine learning, just to call into them.
I want to pick up where you left off, Carl, where you said speech recognition. Today we have, I think Microsoft has the record of error rate of 5.1, which is better than humans. Humans is about 94% error rate. So it basically understands us better than we do.
I'm around 50,
general.
I think, for understanding.
But Microsoft actually made a really good bot. They made a bot which was questionable. The Tay, what's it called? Yeah.
Tay.
But they also made one in China, which is amazing. They did exactly what Carl was talking about. They scoured the internet for conversations, Chinese conversations. But because the language can differ, because China is huge, so it can differ from town to town or apart from different parts. They have solved that with this phonetic stuff, and they are actually getting responses that are real conversations, not just one-offs, because it's intelligent and they know how they speak.
Right.
And that is impressive.
There was a show on recently, I think it was Radiolab, where they were demonstrating this technology from, and I think it was Adobe, that didn't release, and here's why, you'll get it in a second, where you have a video of somebody speaking, and they analyze the audio from that video. From that, build a speech synthesizer, right? And then will allow you to put words in the mouths of the people who are speaking. And then it goes a step further. An analyzer looks at the video, maps all the points of the face, and then generates a 3D model so that you can overlay the person speaking the words they didn't say, and you hear them.
That sounds like a good idea.
Yeah.
Yeah.
It's University of Washington
go
did that.
wrong?
Yeah.
Right.
And they say an expert in video analysis can see where they've meshed the splines, I believe was the line.
That's right.
So that you can actually detect, this is a generated face. We can't tell.
Yeah.
And that's like, the funny thing is, that's going to be a Snapchat filter like in a month.
Well, the outcry from the public was pretty swift and it was pretty accurate, which is, this sort of brings, you want fake news? There's some real fake news right there. I mean, you can make the president of the United States say, I've just sent a nuclear warhead to North Korea or whatever. And, if that gets picked up, it doesn't matter whether it's true or not, or whether it can be verified. It's going to cause problems. You know,
It's very
okay. That brought the conversation to a grinding
Wow,
halt.
I mean, that's,
Yay.
we went to, holy cow, we went from AI to nuclear death winter.
I know. It's
Really fast.
you know, but at least they didn't say Hitler.
All right, of course.
that makes it better.
Yes, of course.
I know if we dive down deep learning, we probably won't come back because I did find the Scientific American article on the pigeons identifying cancer, and I'll include it in the show notes, which it's awesome. But that is simply an example of neural network in action, right? It is a machine learning model. It's just the machines happen to be pigeons.
I guess. I don't know how. I need to look at the paper a little bit more. I thought they were just feeding the pigeon every time.
Exactly. It's more like reinforcement learning.
Yeah, reinforced learning. But that there are algorithmic models that are like that. When you get it right, it reinforces the
Not
equation.
necessarily always neural nets, but
Yeah. So deep learning, if I may, I'm a college dropout. I went to school right during the time when neural networks were out of favor, because what happened is there was 3 periods of time when neural networks came in and left. In the beginning, it was like, I think it was early on. I don't know. I think it was early 90s when the neural networks were really popular, and then they fell out of favor. Yeah. Right. And then they came back again a little bit, and then they fell out of favor. I was in the second deep learning winter where support vector machines were like all the rage, because mathematically they're very beautiful. If anybody knows about support vector machines, and I'm going to talk about them in my talk, they're convex. You can solve them perfectly. So you get a really good model depending on what's going on, and you can do some interesting things. And so that to me was the nicest thing. And I had problems with neural networks because, number one, mathematically they're not convex. And if you don't know what that means, remember when you were in school and you drew x squared and you wanted to solve for the minimum of x squared? It's pretty easy. You just take the first derivative, set it equal to 0, and you have an answer, right? Or wherever the slope
Easy
is 0.
for you.
Yeah,
Well,
everything's easy when you know
It's
what
like a
you're doing.
parabola, right? It's a U.
So at the bottom of the curve, that's why it's convex.
That's the minimum. And so it's a convex function, so it has an absolute minimum. Now, neural networks are not convex. And so neural networks have multiple optimum. And so I was concerned about that. The second concern I had about neural nets, because I was all about SVMs, was that they were not very fast.
Right.
At the time.
Mm-hmm.
They were not very fast. And then the third one is that it wasn't altogether clear to me why they worked.
Right. That's still the complaint today.
And so I actually went to the University of Montreal to speak to a professor by the name of Dr. Yoshua Bengio. And this is online on Channel 9, because I do video stuff sometimes too on the side. And so I talked to him and I asked him about those exact 3 concerns.
Mm-hmm.
And he happens to be, he didn't give up, during the second neural network problems. He did not give up, and he kept doing research, and he found that some of those things that I thought were bad were actually not as bad. He said, yeah, there are multiple optima, but they're all equivalent.
I have no idea what that means. Anybody know what that means? One guy in the front.
So imagine the function x to the 4th. Like if you were to do this in your graphing calculator, it would go like a U down and then would go up like a W and then go down again. And so notice that depending on how x to the 4th is, you have multiple places to find an optimum. There's no absolute minimum.
Okay. When
you set x to the 4th to the first derivative, which is 4x to 0, right? You can get multiple things, right?
Okay.
4x cubed is what you get, and there's 2 or 3. And so now you're like, well, when you're doing your optimization methods, you kind of find one, and do you stay there? Is there one that's better? So when you're optimizing these functions, it's just like you're like walking around in the desert, and you're looking around and like, okay, I'm at the lowest point here, but you never know if you're at the lowest point everywhere. And so that's the problem I had. And he said to me, well, Seth, it turns out that all of the local optimum are equivalent, or they're close enough where it does a good job.
You're not going to have an extraordinarily lower point.
And then I was like, oh, okay, well, that's awesome. Well, you're a professor and I'm a college dropout. You can tell me that and I'll believe you, right? The second problem is that these things were not very fast. And the reason why is in the intermediate nodes, they were using this function called the sigmoid. So if you've ever looked at neural networks, imagine you have a bunch of inputs and you want to have one output, which is like true or false. So let's just say your input is a picture, and your output is there a dog in there or not?
Right.
So imagine the inputs are every pixel times 3 because you have an RGB.
Mm-hmm. Mm-hmm.
So depending on the size of the image, if it's 100 by 100, right? What's 100 squared? times 3.
10,000.
That's how
30,000.
many inputs you have coming in. Times the amount of number of pictures you give it, right? And so these things come in, and then you multiply them all together, and you put them in some intermediate nodes. And I'm drawing them with my hands because that's what you do in audio.
On a radio show.
You're a professional, we can tell.
Right. And so now you have all these things being numerically combined into a node and another one, and you build this huge sort of skyscraper of these nodes where they're all multiplied together. In the middle of them, what you do is you combine those nodes by like doing a dot product, for example, but then you do a function called a sigmoidal. And that's like 1 over 1 plus e to the
How many
something.
people did we lose here?
Am I losing people?
No.
This one guy is sleeping in the back.
But this function is very computationally expensive. It's like 1 over 1 plus e to the something power. Computing that is ridiculous.
Right.
And so if you had to do that for every single input, which we decided is 3,000, times however many nodes in the middle that you have all the way to the output, this is slow.
Yep.
And back then, right, we had our computers with the one processor.
Yeah.
And we only used GPUs to play World of Warcraft.
Right.
If you remember,
Yeah.
if you remember correctly.
Yeah.
And so I go to Dr. Benjio and I'm like, so these are slow. He's like, well, we don't use the sigmoidal anymore. We use a function called the ReLU function in the middle, which is called the rectified linear unit. And this thing in the middle is linear. It's like multiplying two numbers together. Suddenly, all of a sudden, really fast. And it turns out that if you're multiplying a lot of numbers together in like a big sort of lattice, that's exactly what GPUs have been doing since we've been playing World of Warcraft.
Those are scalar functions.
Hey, Richard.
Yeah, buddy.
Guess what time it is now?
Must be that happy time again.
Time for Carl to resist the urge to do a joke about Seth's sigmoidal rectified neural network problems.
I think you can get a cream for that.
I think so, but I'm not sure. It's actually time to give a D-Experience subscription from Developer Express away to one lucky member of the .NET Rocks fan club. Become a UI superhero with DevExpress UI controls and libraries and deliver elegant .NET solutions that address customer needs today and leverage your existing knowledge to build next-generation touch-enabled solutions for tomorrow. Whether it's an Office-inspired application or a data-centric analytics dashboard, DevExpress Universal ships with everything you'll need to build your best without limits or compromise. Learn more and download your free 30-day trial today at devexpress.com/superhero.
All right, buddy. Who's our winner?
Today's winner is Eric B. Potter.
Congratulations, Eric.
And Eric, if you're listening on your commute right now, pull over before you email us, okay? Just
Please, don't hurt yourself.
Yeah. And Eric just won the D-Experience subscription, a big pile of awesome from our friends at DevExpress, just by being a member of the .NET Rocks fan club. And if you don't know what that is, go to .NETRocks.com, click on the big Get Free Stuff button, answer a few questions, and join the fan club. Because we have thousands of members all over the world, and every show we like to give away stuff from our sponsors. And every December we give away a $5,000 technology shopping spree to one lucky member of the fan club, but you got to sign up to win. That's all. And we like to ask our guests too, guys, if you had $5,000 to spend on technology today, what would you buy? Tess?
Ooh, I would buy a Surface Studio to draw on.
Yeah, nice.
Nice. Yeah.
And a bunch of pens.
That's most of your money. That's most of your money gone.
Not a sigmoidal rectifier.
You can't buy those, okay?
Yeah. You can only rent them out by the hour.
That's right. Yeah, you can.
Jess, what about you?
Well, last time I said another HoloLens, but we do have another HoloLens. So I will actually go with Tess's suggestions because those are amazing.
The Surface Studios.
Yeah, the studios. We tried to fit it on our bag when we went to America, but it didn't fit.
It won't make it in the carry-on.
Yeah, no.
That's
And it's amazing.
You have to buy its own seat on the plane, apparently.
There you
Oh, you can do that?
That's what
I
you
don't know.
use
And
the
it would
other
deserve it.
5,000.
You get it buckled in. It's the best seatmate.
You can do that?
Put it in the middle seat.
There you go.
Yeah, okay.
That's the
Seth?
plan.
I would buy a machine with a Tesla in it, and a Tesla is an actual GPU.
Oh, okay.
Oh,
yeah,
right.
that's
The
right.
NVIDIA Tesla.
Yeah, that
Fastest
thing is
GPU in the world.
It's I think it's called a Tesla. He's looking it up. He's like fact checking me as we speak.
No, it's true.
Dude, I like gadgets. I already know where where these ones are, but looking at P100s,
How many teraflops we got?
4.7 for about $5,000. So there you
Teraflops.
go.
Teraflops.
Teraflops.
That's
it's like,
Tera
wow.
is how many? 10 to the 9th?
10 to the 12th?
10 to the 12th
Yeah.
floating point operations per second.
The problem is those numbers are so big, people just don't get it anymore, right?
Yeah, but when in the context of deep learning and the thing I've just told you, each of those rectified linear units count as a flop.
Right.
And if you're doing 4.7 teraflops
Per
then
second.
you're literally doing some learning.
Very fast.
I don't know. But you may be misleading yourself at high velocity too.
That's true. That is true. That's true.
Going back to the comment that Matthew made at the beginning of the show, it's like the quality. I've seen these machine learning models that people put a lot of time and energy into that just give them bad answers.
Yeah.
Well, and that was the third thing that I was concerned about with Professor Dr. Joshua Bengio.
They give you bad answers really quickly.
Does it actually work?
Right.
Yeah.
And he said, because one of the things is, like you said, if you give it bad data, it's going to do a bad thing. There's like certain models like decision trees that Tess is going to talk a little bit about tomorrow, that if you have to curate the data you give it, or it's going to completely flop. Going back to the flop.
See what I did there?
See what I did there?
It'll flop a trillion times. Yeah, teraflop.
But it turns out that deep learning, the reason why it's so cool is you can just give it everything and it knows how to turn off the wrong things. And that's why it actually really works well.
I know that neural networks are used in every device that has handwriting recognition. Like that is a classic neural network problem to solve. And I learned about that. Geez, when was do you remember the tablet PC Microsoft came out with in Windows XP time? It was one of the first tablets.
Motion computing tablet.
No, this was a Windows XP Toshiba
Newton?
device
Yeah.
that had a pen. Is that what you're talking about?
The motion computing. Motion computing was a specialty company that made. I had a couple of them that they in the XP era with the pen, with the electromagnetic pen.
Right, and they actually had an OS called Tablet,
Yeah,
Windows
it was a
XP
tablet
Tablet
edition.
PC.
Right.
Yeah, exactly. So I remember talking to those guys in Redmond, and they're using neural networks in their handwriting recognition, and I think that's a really good example of a success story in neural networks that are still being used today.
Yeah.
Well, I mean, just the services we have.
Yeah. So like for example, the Vision API, I think that's like 150 layer neural network.
Yeah.
What's up with the layers?
Yeah, what's with layers? I don't know.
So-
We're not telling you that.
Yeah,
They're
we
hidden.
can't. We can't.
They're secret.
Well, the thing about so when you get all these inputs in the intermediate layers, those functions in the middle I'm telling you about, they turn stuff on and they turn stuff off, and then at higher levels they combine stuff together. It's like it literally learns to find a dog in that picture I was telling you about with the 3000.
So for example, like in the Vision API, like big overview, like the first. Well, I'm not going to go through the 150 layers, but there's like one layer that turns it black and white and looks for like left edges and right edges and things like that. And then the next one might put together like 4 edges to make a square.
or a histogram or something. So
Yeah.
I get it. So the layers are just different methods of attacking the problem.
They are, but the thing is that we're not telling the computer which layer does what. It does its own activation of things inside of it. So
Based on its result.
What we're doing is we're literally, because remember how I told you that you take the derivative and you set it equal to 0 and you find a minimum?
No, but if you say
remember
so.
with the x squared thing, what you're doing with a neural network is you're passing the data forward, which is finding a function value.
Yeah.
And then you're going backwards, which finds the derivative, and you keep hill climbing that, or well, not hill, you keep going down until you find an optimum. And so this thing is like that Knight Rider. Remember Knight Rider? That
Trying
thing at
to
the
forget,
beginning?
actually.
That's exactly, like every time I go through like the process of, I guess it's called stochastic gradient descent, if you want
Obviously.
to look it up.
It's like the Cylon eyes.
I didn't finish college. So anyways, like it goes forward and backward with each example until it comes up with a way to combine things to actually learn the right thing. Is this a dog or not? Now, once you've learned a dog, how does it know, for example, like you give it a picture of like 10 dogs. How does it count how many dogs are in there? Well, you just put a little box, and just like Knight Rider, you go across the entire image and you find the right thing. And then that's how it puts boxes around it.
But it is like, so when you're talking about deep learning, as opposed to like just regular machine learning kind of, a big part of machine learning is kind of finding out what features to use and like, so what data you're going to actually feed it. I'm going to do like a house example. And is it like the area or the amount of land or what type of house or whatnot? What's going to actually matter in the equation to find the price of a house? But with deep learning, the machine finds out for
you just give it everything.
this is not the only way that machine learning works, not just the neural nets, the deep learning model. There are other models. I mean, I come from the old era of OLAP and so forth, where we had a bunch of data mining algorithms, but it seems like they've sort of consolidated down on the prune tree. Like that is the other method that seems to matter.
Oh, there are plenty of other methods.
Yeah, I know. Do any of them matter?
Yeah, I think so. Well, I'm kind of like newish in this field, but I mean, like you were talking, there are 5 different types of questions you can ask. And depending on what question you ask, like, for example, if it's a regression, so how much or how many of something, like how much is this stock going to be on Tuesday? Then you have certain methods, like linear regression or naive Bayes or a couple of those. And then you have Bayesian.
Bayesian?
Bayesian.
Bayesian, yeah.
And then on the other hand, if you want to classify something, is this a dog in the picture? Then you have totally different kind of algorithms, and they all fit a different type of data. Like data with lots of features or data with lots of items.
And for developers who want to utilize these things, I think that's where the trick is, right? To figure out which algorithm do I use based on, what my data is and what I'm looking for and what questions do I need to ask.
Here's an
that's
example.
part of the problem. Yeah. I mean, the bigger part of the problem, I think, for those is to actually get good data.
Yeah.
Because there's only even if there are a lot of algorithms, there are only so many that you can kind of try a lot of them.
So it's like, you know how when people think about science as like, I've got this down to a science, I don't think it means quite that, what they think it means. To me, science is glorified guess and check. And data science is glorified guess and check with data.
Yeah.
And so you get your data and you look at it and you're like, okay, I want to be able to predict this thing. And then you figure out that Jim in the back has always been putting the name in the age field. And you're like, come on, Jim. And so you spend a lot of your time fixing
Cleaning
what Jim
it.
did.
Yeah.
And then afterwards you put it in the model and then you figure out, Sally's been putting the things like times 10 into the because for some reason she thought this was in tenths of pennies or something. And so almost the majority of data science time is spent either cleaning data, understanding data, and you might even get to a point where you look at your data in like let's just say using Power BI to visualize, and you might find out that one particular feature completely determines the outcome of this other feature that you're trying to predict. So you never use a model because you don't have to. So like Excel is your data science tool, for example. Right. And so data is a very important part, and it's not a sexy job. You're like imagine you ever seen the show Dirty Jobs?
Yeah.
They should have they should have like the database guy from a bank be on the job. It's literally dirty jobs, right? He's literally trying to clean all this data up until we get to the point where we do the modeling, which is the part we love the best, and this is the part we talk about. But there is a lot of extra work that goes into making
talk for yourself. I kind of like the exploration thing.
She does.
Okay.
See, that's why we got to have all kinds of people.
Oh, that's
the
great,
college
though.
dropouts and then the experts.
Well, it seems like you're perfectly suited to that job then, if that's something that you really like.
I love data. I mean, I've been collecting data forever, not knowing what I should do with it.
She has a large cutout of Data, the guy from Star Trek.
That too. I've been collecting him a lot.
Accessing.
Love data.
What are the other aspects that are under the AI umbrella we haven't talked about?
I don't know. What's the next marketing guy going to talk about?
Yeah, right.
I'm just waiting for everything to come together to one big Skynet, if you will, but a nice Skynet. Is there such thing?
Are you talking about person of interest?
Yeah, kind of like that, because I have so many connected things in my home. Like Cortana knows, she runs my life. Google runs my life. They know everything about me.
My
they know
wife
what I shop.
runs
They know
my life.
She's your AI.
Yeah, she's your AI.
Now, we haven't talked about the bad parts of like using that knowledge, but maybe we shouldn't go down that rabbit hole.
I actually have a friend.
I do think there's a non-trivial ethical debate right now when we talk about the sheer amount of power that's available to us by the hour or by the minute. Certainly these tools are perfectly capable of doing inappropriate things. We were talking about the University of Washington with their Obama generator. That's what they tested it with. Like you talk about fake news, that's a whole other level we could be using these tools for.
I don't think we have to worry about like the Terminator killing us, right? Because that's like, and I'm going to quote Andrew Ng, because there's other like great like computer people that are like, I'm really worried about AI and killing us all. And I'm always thinking like, well, maybe you should stay in your lane, right? Because Andrew Ng, who is definitely a machine learning expert, said worrying about the killer AI is like worrying about overpopulation on Mars. Like we're going to get to Mars eventually.
Yeah. Right.
And we're going to live there. But let's worry about the overpopulation problem when we're even close to it. Because current computational models, in my opinion, will never have this thing that people like to call emergent AI.
But the other part, which is data mining and using that data mining for not good.
And here's an example of that. For example, let's just say you want to predict like who is going to commit a crime. Now, you do your data modeling, and it turns out that this one area, and in the United States, let's just say it's this one area where it's predominantly African Americans. Well, maybe the police in that area are arresting too many African Americans.
Right.
And so the data that you give the computer will completely determine the outcome of the actual algorithm. So when you think about things like Tay, if you let a teenager out on the internet and let it learn from whatever on the internet via DMs, what do you think it's going to learn?
What do you think it did learn?
And so to me, and I'm speaking on behalf of myself, as an AI practitioner, it was a complete success.
Right.
Because it showed the complete depravity of humanity on the internet.
Right.
That's an example of AI used bad, not because the computer was bad, it's because we suck as humans.
But also, you're looking for correlations, and there has to be like a 200% difference in a correlation in order to make it significant that you might actually think there's a cause. And there's a lot of great examples of this and metaphors, and one of my favorites is, every time a house burns down and there's a fire at a house, there seems to be a lot of firemen there. And so what I think we ought to do to prevent fires is kill all the firemen. Because clearly they're always there. That's very suspicious. Another one is people are a lot more likely to die in an ambulance than any other car. So if you want to not die, don't ever get into an ambulance.
So here's an ethical question. Let's say you could kind of through looking at what people search for, you can find out. You can look at a long history and find out this person, for example, has a disease. You find out ground truth they have a disease because they said, hey, I have this disease. What do I do now? And then you look back and you find out what they've been having, like what kind of symptoms they've been having, like 6 months back or a year back. And this is completely possible. Then how do you handle that when you know someone has such a symptom and they could have a very bad disease? How do you tell them that?
Right.
Well, I mean, we've already seen these situations where the marketers have figured out that someone's pregnant before they realize they're pregnant. Or much more importantly, their fathers are aware they're pregnant.
Yeah, get diapers in the mail.
Yeah.
Samples.
Well, and also because in like when you're on Facebook or whatever, the ads that come, is it weird that you're looking at an ad and you're like, I do want that. How does it help? Right? Because there is an inordinate amount of human ingenuity right now in the AI space. Like if you put together like the human ingenuity and the effort that's being placed into putting an ad in front of you, we could all be living on Mars right now and worrying about this overpopulation problem. Right?
So here is something that they should use AI for. Figuring out if you bought that thing and then removing
Stop
that
showing
ad.
the ad.
But
I find
apparently
it very enjoyable to contact the company I bought something from and says, I'm going to return this unless you get rid of these ads.
But apparently we ask about that because it's annoying, especially if you're two people who have birthdays around in January, February. So we have December, January and February, we have to, in our house, sneak into Facebook without the other one looking because we forget about in private browsing and stuff like that. But
because otherwise you tip off the others what present you got them based on the ads that are showing.
But apparently there are like 90% of the people who get the ads actually already bought the item.
Right.
But it's still profitable to show it to just catch those 10%. So that's why they annoy us.
But isn't there like a 65% of all shopping carts are abandoned? So if you put something into a shopping cart, you don't buy it, you'll probably still see the ad for it. So, there's at least that, I guess, what they're going for.
That's a perfect actually use for machine learning and AI to figure out why those shopping carts are abandoned.
You know, the best way to screw your friends up on Facebook is to just like everything.
Yeah, right. That's true.
Because there actually is an algorithm called collaborative filtering that it probably uses, which is not deep learning, which means that anytime you like something, right, the computer is going to make some kind of assumption that your friends like something. Mm-hmm. And so this dude, like, I don't know if it was an article, he went and just started liking every single thing that Facebook showed him. And there was just weirdness all around.
That's great.
So go home and do that.
That's how we can subvert the system. Stick it to the man.
Like, it's kind of like I saw this like lo-fi way of like subverting face detection. People put like tape all over their face.
Yeah.
Did you see this? You got to find that and put that in the show notes. It's hilarious.
You could also print out a color picture of somebody else's face and just put it right over your face with some cutouts for the eyes.
But not with the Apple ID. Apparently that doesn't work.
Oh, it doesn't?
It's infrared, so you'll have to use infrared tape.
Speaking of Apple, there's this guy in Springfield, Missouri, and he likes home automation and connecting stuff, and he went out and bought basically everything that said works with Apple HomeKit. And there was like the Philips Hue light bulbs and sensors and there was this smart August lock, I think it's called. And he was so excited. He was calling over his friend who's also a neighbor. And he was like, look at this. I can even unlock at work. I can unlock the front door for the dog walker without even giving him a key, because giving him a key is actually a security risk, right?
Mm-hmm. Right.
And he showed that he had this iPad in the middle of the room, and he could say, "Hey Siri, turn off the lights." And he was like, "Oh, this is amazing." And his friend was, "Oh, that's super cool. You live in the future." And then the day after, when he was driving home from work, he pulled in and he was getting some stuff out of the car, and his friend said, "Hey, could I borrow a cup of flour from you?" And he's like, "Yeah, sure. Just let me grab my stuff." And he's like, No. And he went up to the front door and he just shouted in, "Hey Siri, open the door."
Yeah. That's why I don't turn any of that stuff on, because my daughter, I pick her up in the car and she's like, "Hey Siri, delete all my apps," or whatever. I'm like, so, we were talking about nefarious uses and things and Big Brother, and Seth, we were talking about this last night, is that we think that Big Brother is nothing. I mean, people you should be worried about is you and ourselves. Like we share all these things about our lives without sometimes knowing it and sometimes without even knowing it.
Yeah, the moral outrage when someone finds out they're being surveilled is rather comedic.
It's kind of funny.
Seeing that the very second after their moral outrage has been felt, they post it into a place that monitors every single thing they do at any time. And they willingly paste all their friends, all their information. Right. They click on ads there, but their moral outrage is placed again in the very place that surveils them the most.
And I think we're going to leave it with that. Big round of applause for our panel.
We'll see you next time on .NET Rocks!
.NET Rocks is brought to you by Franklin's Net and produced by Pwop Studios, a full-service audio, video, and post-production facility located physically in New London, Connecticut, and of course in the cloud. Online at pwop.com. Visit our website at dotnetrocks.com for RSS feeds, downloads, mobile apps, comments, and access to the full archives going back to show number 1, recorded in September 2002. And make sure you check out our sponsors. They keep us in business. Now go write some code. See you next time.
Got transmitter banned by the FCC. Yes, I'm a